places like Ohio, northern Ohio, and parts of New England, and only the very tip tops of mountains stuck out. Again, I mentioned the recession, again from the last glacial maximum. Here you can see the beginnings of the Great Lakes as the ice recedes at 13,500 in the last glacial. These start to fill up parts of the Great Lakes basins here. And they've been scoured out by the glaciers, now filling with water. But by 12,000 years ago, you know this if you've been with me on the Niagara trip, at 12,300 we have the start of the Niagara River, which means that connection between Lake Erie and Ontario was completed by backing the ice. That was 12,300. By 12,000, the ice had receded even north of Lake Ontario. So you get that sense. And of course, by 9,000, still much of Canada was under ice, and a huge lake here called Lake Agassiz was formed, a rather shallow lake over a lot of the Canadian prairie of today. Now, of course, as the ice receded, it left its record. Where it was stationary at points, you got glacial moraines. Of course, there are different types of moraines. You can learn a huge amount on this stuff from Tom Lowell in this department or from Lewis Owen. But these are ridges of debris. You can see modern moraines, and you can see a number of them in Ohio. We're right down near the terminal moraine. Some of that terminal moraine was the final one, is down as far as sort of, Sharonville, in that region, just in the north part of Cincinnati. So there you have it. And of course, all the various sculpturing features and both erosional and depositional topography. You got the nice U-shaped valleys cut out of originally V-shaped valleys and widened. And of course, you got things like terminal moraines, esters, kettle lakes. Learn more about it as you wish. Other effects of glaciation include climate change, of course. Often in some areas, there is an increased precipitation. Other places, it's actually drier. But in the American West, the area of the Basin Range, which is today quite arid, during glacial times, this was a much more humid area, and it filled up with great lakes, big lakes, I should say, not big lakes. Depression by ice causes the land to be sunk down, and then as the ice recedes, it rises up. In some places, there's been more than 100 feet of glacial rebound just since about 15,000 and 18,000 years ago. So this can really change drainage patterns very much. You get a drop in sea level because you freeze up all that water and ice. You know that very well. And of course, you get the change, diversion of streams. I already mentioned the Ohio, Niagara, Missouri, and others were all rerouted due to glacial action. The lower sea level allowed Beringia, the land between Asia and North America, to be exposed. And that meant, oddly enough, there was an ice-free corridor that organisms could cross, including horses going out of North America this way, mammoths and mastodons coming this way, and maybe, probably, humans coming across. And exactly when is a little much a matter of debate, but probably about 13, 14,000 years ago, maybe earlier too. This is simply showing the pathway of mammoths coming out of Africa. Oh, I love this picture. It looks like a Corvallis hunting sports calendar, but this is not as exciting anymore as it was during the Pleistocene up in Alaska, but you can see that ice-free corridor with all kinds of animals, some of which are still extant, like the bighorn sheep and muskox and bear, but others not, like the horses. They survived in Asia, but not here. Of course, the big mammoths, the elk moose, which is gone. Bison made it through. And Now, another thing that happened during this time is the so-called pluvial lakes. These are due to times of greater humidity. I already mentioned you've got these great big lakes and meltwater lakes as well, melting of glaciers. And these caused very interesting things in the American West. Some of the last things that happened out there are quite dramatic. Lake Bonneville, this is where Great Salt Lake is today. The Great Lake, we have now a remnant of a lake which is almost dried up and almost gone. But it's just an extremely salty playa lake there now. And in places, you get the Bonneville salt flats. I'll tell you a story about those on Monday, why you should be very careful if you go racing vehicles. Look, the Bonneville flats. But there's some remnants which are now just salt flats. But go back to the Pleistocene. not so many thousands of years ago, you had a Great Lake Bonneville there. Great Lake Bonneville. Here's Salt Lake. That's a remnant. Now, back in the Pleistocene, you had 1,000-foot lake there. 1,000 feet deep. Look at this. If you go to the terraces around Salt Lake City, this is the Wasatch Range. By the way, a fault right at the edge of the Basin Range. That is the very edge. There's the Rockies, there's the Basin Range out here. And you look at there, you see terrace. And here, terrace. These are old benches cut by waves. And when you look at that history, it's very amazing. It's right in Salt Lake City. You've got this, this bench up at about 5,085 feet. Another one, which is called the Provo level, about 4,000 something, 100 some feet. On Lake Bonneville Stansbury level, down at 4,400. Modern Great Salt Lake is down here. This shows that at one time in the Pleistocene, this lake was flooded up to here. It was a huge freshwater lake and had fish in it and so on. But catastrophically, it dropped, and it dropped, and it dropped, and now it's drying up. Why did it drop? Because there was a lava dam up in here going into Idaho, which was a spillway of that lake. And there were periods where that cut through, erosion cut through, and then new lava. And when that happened, then the lake level dropped. And it catastrophically flooded up into what's called the American Falls Lake and the Snake River of Idaho. And it just dropped the lake probably within a few years by 100 feet or more. And so you get these multiple stages. But the picture that's shown there on the right-hand side is really the dramatic story of all. And that is evidence for one of the greatest floods, catastrophic floods that we know of. I think probably the drainage of Bonneville was pretty catastrophic, but this one has really been kicked around a lot as an example of catastrophism in the modern. And this is the result of damming of the Great Lake Missoula. Great Lake Missoula occupied a great deal of the area which is today Montana. It was a pretty large volume lake. It was trapped on one side by ice, and it was trapped in front by ice. It was a so-called ice cork, or ice dam, which held this lake back. But it's thought that at times, when this lake flooded to particularly high heights, when the ice was starting to melt, and you're getting a lot more runoff, then the buoyancy of that ice lifted the dam like a cork, and that dam blew out instantly, and this caused enormous drainage to the west, producing a huge area called the Channeled Scablands. This is what the Channeled Scablands look like from space, from the air. And you see all this network of cut canyons. Those are those flood basalts, the Columbia River basalts cut into. It's thought that many of these canyons were cut within weeks or months after the flooding. The last big flooding, there may have been multiples, was probably about 18,000 years ago. And it created this landscape, which is quite dramatic. Here you can see these are large anti-dunes. You remember anti-dunes are formed at very high velocity, and they were produced by sediment being moved down this huge river. This is the Grand Coulee. There's a famous Grand Coulee Dam downstream, but here these are flood basalts. That's hard basaltic rock. Probably most of that canyon was cut within a period of months, if not even shorter, by the enormous volume of water flooding from Lake Missoula when it topped its cork. So it topped its cork, ice cork, and out it flowed to the west, creating a most amazing region. It was hugely debated. Then this guy named Harlan Bretz, B-R-E-T-Z, from the University of Chicago, finally made the point this was all the result of these huge floods. And that was a huge mind changer. It was a game changer because that was maybe, I guess in the 1970s, and at that time, everybody thought of Earth processes being kind of gradual and slow and continuous, like Lyle had said. But no! In Earth history, there are these episodes of extraordinary action where, within a very short period of time, major things can happen. So the Great Missoula Flood is not only famous just as a Pleistocene record of a big lake that flooded, but it's kind of important in the whole philosophy of geology. Alrighty. And last but not least, we'll have to say a little bit about Quaternary life. What was going on in this last 2.6 million years of Earth history and life? Well, you can see that many of the trends that were already in motion continued. There were huge barrier reefs. I don't know, do I have pictures? Maybe. Oh, that's a chance. Scablands. Yeah, the Great Barrier Reef is developed mostly in the late Pleistocene. It's mostly the buildup of just a transgression in the last few thousands of years. Okay, but we see a lot of interesting things in the history of terrestrial life. Yes, there's that famous Cabela's picture. There's been immigration to North America from the south of things like giant ground sloths and huge glyptodonts. They survived in the area around what's today Los Angeles. You go there, you're on one of the most famous of all fossil localities in must go called La Brea. And in La Brea, we see late Pleistocene animals as they existed at a time before mass extinction. And there are these things. And you even have some of these all the way up to Big Bone Lick in Kentucky. That's actually Jefferson's ground sloth way up here. So La Brea should see from about 50,000 BP to about 11,000. There were still these. There were tar seeps coming up from Miocene tar-rich sediments below, full of oil, petroleum, and on the surface was water floating. And these things then became traps because animals came to them to drink water, and they got mired down in the tar, some of them. And there's a disproportionate number of carnivores because probably carnivores came in after their victims, and they got stuck, and then other carnivores and scavengers came after them. And we have this record, sorry, I didn't take it down from that. So we have this record right in downtown Los Angeles is where you get to see where these tar pits actually are. Sorry, did you say something? I heard it wrong. But yeah, Los Angeles is a dangerous place, probably more now than it was then. But yeah, these are the tar pits. And at that time, a lot of interesting stuff going on. Bison or North American lions living there, big sloths, and so on. Another wonderful scene of the North American lions going after a bison out there. Okay, whereas further towards the glacier front, there were big animals like the giant Irish elephant. I forgot what happened to that slide. But anyway, it had these giant antlers in Europe that lived right up into the later Pleistocene. And of course, mastodons and mammoths, two very different types of proboscideans or elephant relatives that had, we know, this brown fur and so on. We know this because in the Arctic permafrost, there are places where these things have been entombed in the frost since maybe 20,000 years ago. They're refrigerated instantly. They have buttercups in their mouths. They know they're grazing on the periphery of glaciers, but they were entombed in times of probably melted permafrost. They got into that, and their bodies were mummified or refrigerated, really. So the meat is still edible. At least dogs discovered them, and people have eaten that meat too. So we know a bit about, they had, by the way, mammoths had very distinct elephant-like teeth for grinding the tough C4 plants, whereas mastodons were smaller, also covered with brown fur, but had more sort of nubby cusps, as you remember. Cuvier himself called them breast teeth, and this is mastodon, and these were partitioning the resources with the mammoths. They were doing things differently. And the Big Bone Lick, just 15, 20,000 years ago, maybe even less, 9,000, you had communities of these things living there. But amazingly enough, they were also living alongside humans. And we know that humans butchered. In fact, about 40% of the fossil mammoth mastodon sites in North America show evidence of butchering, cut marks in the bones, and so on. Perhaps they drove them out on thin ice in the winter and were able to trap them, but rather, people are rather smart and clever, and they have been able to hunt even these big animals. They even refrigerated the meat. There's some refrigerated meat caches that have been discovered in Michigan, where the early Native Americans put down chunks of meat in sort of bags and weighted them down with stones and let them be refrigerated under ponds during the spring. Okay, and lastly, of course, we can go from these things in North America with open questions like, why did all those things disappear so recently? And I think you know the answer. And the answer is it really resides in what happened slightly earlier in Africa. It's all out of Africa. And we go back to the Pleistocene. That's really almost at the boundary of Pleistocene as we now know, because we used to always say 1.8. Now we put Pleistocene back to 2.6. And almost at that boundary, maybe at around 2.4, we have the evolution of early Homo, our own genus in Africa. And you know, probably, that some of the early things, early representatives around 2.4 were things like Homo habilis. Homo is different from the Australopithecines in a number of ways, but most particularly in a greatly expanded brain capacity. Of course, we count this up and down. We know that modern humans have something usually more than 1350 cc brain capacities compared with Lucy back here, which spans only 500. So a huge increase in brain size, and that's been brought about by a very odd quirk of evolution, which allows humans not only to develop a pretty good sized head in utero, but, and of course, here's a real limitation, you can only make the damn head so big, at least in the time before C-sections, because it just can't get through the birth canal. So, humans had an additional twist to their evolution. That is, after birth, they were able to continue their rapid brain trajectory for up to 1 year. Look at that. On the same pathway, whereas a chimpanzee at birth has a not so much smaller brain than human, but it just stops growing. But here, humans do it. This could only be possible by having, first of all, an upright walking organism where the mothers could take care of the young, not in trees, but on the ground. So all that may ultimately stem from climate change in the Miocene, but here you have the culmination of this trend. It means bigger brain organisms, and you can see what a difference that makes. You continue to grow brain for a while, but you can see it's really fast in this first year, even after birth. So this is a big deal. Homo habilis was the first that began this trend with about a 700, 800 cc brain capacity. And Homo habilis lived in Africa in the Great Rift Valley, starting around 2.4 million years ago. And large cranium, flattening of the face, human thing, and the famous Olduvai Gorge choppers. These were stones that were clearly fashioned to make choppers, to cut meat and so on. And so you have humans using tools. It's not so clear that the Australopithecines used this type of stone tools, but coincident about with the first evidence of Homo, our own genus, you have Homo erectus, very famous species, which spread out of Africa probably somewhere around 2 million years ago. We know that already by 1.9, they show up all the way over in here, where the Asian man, or Pekin man, as it was originally described, by the way, found by a paleontologist from our department. You don't know that. Barber, you've heard of the Barber Award that's given here in humanities, but this guy was a paleontologist. He went and helped to discover Peking man. And this was a very important thing. It showed that this was a hominid that had the ability to move out of Africa and to colonize here, colonize into Europe, and probably gave rise to the Neanderthal group up in here, whereas back in Africa, something like Erectus was close to the origin of modern Homo sapiens. And you know, these guys made tools also. The Apulian axes at about 800,000 years were made in Kenya by Homo erectus. By 600,000 years, you have something pretty modern, found also in the middle of, not just in Africa, but in the Middle East and in Germany, obviously. Heidelbergensis, named for the Heidelberg Valley in Germany, is almost an intermediate between modern Homo sapiens and something like Erectus. So that was spread out of Africa too, and probably we should note that somewhere, maybe starting as early as about 530 million years ago, and extending up to only just 32,000, that's 530,000 years ago, up to about 32,000, Neanderthals evolved in Europe. And you can see there's a lot of differences. You can study on here all the differences of the skull, the more nasal protrusion, the bun at the back of the skull, and so on. They're different morphologically from modern Homo sapiens, but they clearly overlap with them. And this is a good question. Did modern humans drive them out? Possibly. Well, one thing we know that modern humans did do, in addition to perhaps driving them down, was that they had their little fun with the Neanderthals, that they interbred with Neanderthals, because most Europeans contain now known some fraction of Neanderthal DNA, which has only been recently extracted from the bones and compared with modern humans to say, well, yes, and this raises the question all over again. Were they really different species? Because technically, usually species can interbreed to produce fertile offspring, and yet we know Neanderthals and modern humans. They made their own type of tools, the Mousterian flints, around 150,000 to 28,000 years ago in Europe, Neanderthal Valley. We know that they were not dumb at all. They had larger brain capacities than Homo sapiens, actually, by a bit. But, you know, they had different habits, but they also buried their dead in ceremonies, as from the Zagros Mountains in Iraq, the painting of these things doing just that. Modern Homo sapiens, finally. Well, modern Homo sapiens are Cro-Magnon man, Cro-Magnon man, from modern cranial evidence. Yeah, you've got lots of different guesstimates as to this. So more than 300,000 years ago in Africa, or more, or just a few years ago, we were just saying about 160,000. But if you construe that Neanderthal was a sister group to our species, or even just a subspecies, then we would have to admit that probably modern Cro-Magnon man or humans go back to at least as long as the Neanderthals, which is getting back past 500,000 years. Yeah. So maybe that far. It is thought that all humans, modern Homo sapiens, came out of Africa. There's the same so-called mitochondrial Eve that's been done by genetics work and so on. And of course, this group really began to take over in the world. They competed with, and perhaps had their intimate moments with, the Neanderthal in Europe. But ultimately, the Neanderthal fell away, and the humans proliferated around the continents. Differentiating into races only in the last few thousands of years. One group obviously made it into the previously isolated Americas, crossing Beringia, the Bering Land Strait, somewhere around in the 13, but this is controversial as well, 1,000. And they formed the very early hunters in North America, the Clovis hunters. Something happened to the Clovis hunters, and something happened to large mammals at about the same time. There are certainly various ideas. Many people have argued now for some decades, based on all the butcher marks that we see, that humans, with overkill, with their ability, their smartness to outsmart big animals like mastodons and to drive herds of things over cliffs, as we know they did, bison and so on, that they were actually producing a wave of extinctions already in around 12,000 years ago and so on, culminating around this time, around 12,900. There's a time where there was a brief period of strong cooling. This is post-glacial, because we're into the Holocene at this point. But this glacial, little return to glaciers, and it's not the Little Ice Age, but it's called the Younger Dryas, somewhere around this time, is about the time where a lot of these big mammals take a major hit. But so did the human cultures at the time, or so we think. So a new idea has come along the pipe just in the last decade or so, and that is that there is increasing evidence that there may have been a cometary impact at around the time of the Younger Dryas that caused the cooling ultimately, which produced spherules, maybe tektites, soot, nanodiamonds, tiny diamonds, a lot of places, and also blankets of sediment that even fill in mammoth tracks at about the time of the end of the Clovis culture of hunters, which is this group that you see in New Mexico, 13,000 years. So, it's an interesting thing. Was it humans that really caused the demise of these big animals? Or was it that something extrinsic, like a big impact, again, produced the demise of not only a lot of the big animals, but also a temporary demise of human culture in North America? Looks like that impact was ground zero, somewhere up here, around Hudson Bay, and we find material spread around that is being studied actively by Ken Tankersley of the Anthropology Department and others. So it's a really interesting idea. I don't doubt, though, that humans had their had their impact too. And I think that probably, like many things, it was a combination. It wasn't just climate change. After all, we've had glacial, interglacial, time and time again with no major impact, animals simply tracking their environments. But here, something clearly was a break point. And maybe it was, in part, physical, an impact, and maybe it was partly human-induced, biological, overkill, it's called. And this is a very interesting idea. So, yeah, so, you end up there with an interesting new issue. And that issue is Holocene really the last part of geological time? In the last 5 years or so, people have begun to advocate for this, what they call the Anthropocene. What would you use as evidence for? What do you see? Lots of impact by humans. I would say for the first time, but I'm not sure when that starts, one species on the planet is controlling everything. Lots. Climate. Tom Lowell has pointed out to me that more sediment is moved by bulldozers now than by all the natural rivers and ice. That's a pretty staggering number. That's pretty impressive that one species can do this. And of course, I think that it's a scary thought because we have potential for great damage and have done, maybe even starting with the overkill of these large mammals. But we also have potential for great good. This is, of course, Cro-Magnon art from 15,000 years ago. So humans are a really special species. And those who would like to start the Anthropocene as a real epoch, the end would say, well, 1950. Okay, I'm born in the Anthropocene, I guess. But, just barely. But 1950 because we have there a record that could be tangibly found in stratigraphy, and that is the record of exploding nuclear bombs. Nuclear bombs were exploded. There's a big pulse of carbon-14 at that time, can be dated, can be noted, and some people would say, we start the Anthropocene at 1950. Why not? I like that. So I started about then too. So last pictures, I think, on this one. Yeah, so these are just pictures of and all these things. They lived so recently that it's amazing to think that, why are they not here? Well, I think that between us and maybe a cometary impact is we have the answer. But no doubt that extinction isn't done, and I think that we have had a lot to do with it. That was Homo erectus in the previous picture, waving his big stick, whatever. But this is Neanderthals. Anyhow, that's my main last slide. I don't want to end the course with a skull or with a gloom and doom that, well, we're in the Anthropocene now and we're doing everything wrong. I have strong optimism that we can do things right and that humans have the potential not only for tremendous harm to the planet, but also tremendous new things. And so rather than ending it with that, I end with this last swing for your... Now, here's an interesting case of contingency because one artist conceives that had it not been for the great Cretaceous Cenozoic impact, that instead of having hominid skulls like the one we saw, we'd have something like this. This is an odd reconstruction of a dinosaurian humanoid, I guess, if you will. But contingency being what it is, we don't have that, and we do have a flourishing of mammals, including the one species that continues to do lots of damage. I'll show you these last. This is just a sort of a little personal prologue, or end, for this course. Just because I want to tell you that I have a long history of interest, enthusiasm in this stuff, as you might imagine. And these go back away some. This is a sign I saw on a quarry, and of course I like this sign because it tells me something. This is what the general public thinks about rocks, about geology. Dangerous things, keep them away, cover them up. I saw a sign like that and I said, that's where I want to go. I want to go in that quarry for more dangerous stuff because there's more rock exposed. Sometimes you see signs like this when you're running field trips, you're like, oh my gosh, we have to get going and have a wonderful day. This little dark patch, this is interesting sort because this is my very first field trip with college students almost 40 years ago, and that was at Cincinnati looking at at the Cherokee Unconformity. You can see I was pretty excited at that time. Not much less excited now. I'm pretty much the same. And here's another one. This is a picture of a field trip in Pennsylvania showing me, of course, leading this trip, this roaring away. And this guy was a religious studies student who came on it for an easy grade. I said, well, there you go. Well, here's something that will challenge you a little bit. And he's just thinking, my God, this guy's crazy. Man. Because the next thing I showed him is that get down on your knees here and take a look at this. This is a wonderful example of cross-cutting relationships that you remember right back from the beginning of the class is now on the internet as a classic example. I showed them, hey, look, that's a possum. That was a possum living, and it got rolled over by a car, and then the white stripe was put right across its back. You can see the different cross-cutting relationships in that. And this is a trip from way back where I was bringing students to show them the Cincinnatian. You know, I loved that stuff when I was a kid. I either wanted to work on Cincinnatian or up in New York. I worked on both. But here we went out to Waynesville and said, I think the trilobite beds are here. You can see the students all lined up. Turns out the trilobite bed was down there. They didn't get any, but till the very end, somebody said, hey, oh, okay. But I didn't know. I didn't live here then. And of course, here we are scraping our boots off in suburbia. Why not? We're there. And sometimes when students are really hot, they do weird things. I didn't do it, but they did, and they're all skinny dipping in the Snake River. Okay, so it's just wonderful things in geology. I hope at the very least I've given you some tendency to think about everything that you see driving by, you know, every road cut. The best thing to me is when students write back to me and say, I can't get by road cuts anymore without wanting to get out and ask what is in those things. Those are amazing geology. We're working on this area. This is the haystacks of South China and Vietnam, where these are Devonian. We're going there to study the coral reefs that are in those. But those are weird karst topography. Just incredible that things like this exist on a planet. But as a geologist and a historical geologist, you are working in this kind of terrain, and it's a wonderful thing. Till the sun goes down, but you know me, I don't even give up then. I just keep going in the headlights until the sun comes back up again, sometimes. So as the sun rises, I think, here in the Caribbean, I finally come to the end. So thank you very much for all your attention. At least you should applaud our TA. So I'll see you all on Monday. And,